Hi everyone, let's go to problem number 7 on AIME 2024, the first one. All right, so find the largest possible real part of 75. So we got 75 plus 117i, 117i times z, and of course we got to write it a plus bi for sure. And this would be, in fact, a classic example of Cauchy-Schwarz. 96 plus 144i, 144i divided out by a plus bi. Okay. And I need to find out the largest possible real part of this expressions where z is going to be absolute value of z, which is going to be absolute value of a plus bi, supposed to be 4. Okay. All right, so I know that a squared plus b squared is supposed to be 16 for sure. Now, I'm not sure how we're going to use that, but let's just first try to look at this expressions, and we get 75a, and of course we're only maximizing the real part, I would say, so I don't have to care about all the I part, so I'm going to get rid of all the I parts. I have negative 117b for sure, and what about the 96 plus 144i? Well, I would say we got some a squared and b squared in the bottom part, and we can also write it as 96 plus 144i, and we're going to subtracting this by a minus bi for sure. All right, so let's just try to extend this line out here, and of course we don't care anything about I part, so I would say we still have this 75a minus 117b for sure, and of course we got some 96 let's erase this, plus 96a divided out by a squared and b squared, right? And of course, we get something like 144b over a squared and b squared. Okay. Now, of course, all the other parts are just like imaginary parts. We don't care about the imaginary parts. So what I just did was that if I move it right here, I get the real part of the whole thing, and that becomes this much, right? That becomes this much. And of course, I've been simplifying all of these expressions. All right, so I got some a squared and b squared, and that's supposed to be just a real number, I would say. This is already like 16, right? So we know that a squared and b squared is supposed to be 16. So if I rearrange this, that becomes 75a minus 117b. And I know that these are 96a divided out by 16. And we got 144b divided out by 16 as well. All right, so that being said, I can actually write 75a, and we have minus 117b. What about this? That becomes 6 times a. What about 144 divided out by 16? I know that's like 12 squared. So 12 squared definitely contains some of those numbers. So I like some of those, like 16 out there. And if I multiply it out by 9 to 16, I get 144. So I think it can be simplified into 9b as well. All right, so I got some 81a. And what is this? That becomes like negative 108. Is that negative 108? Yes, negative 108b. And I need to maximize this. Right, so how do I maximize this? Well, in order to maximize this, I would say this should be maximized as long as we have 81a minus 108b squared supposed to be smaller than or equal to, I'm going to say smaller than or equal to 81 squared plus 108 squared, which is negative 108 squared. Let me just write it. What? Never gets erased? Oh no. Oh, there we go. Plus negative 108 squared. And I'm dividing this. Let me enlarge this so that we get a squared plus b squared. This is 16 for sure. And what is this? 81 squared. I would say these are 9 times 9 squared. So 9 times 9. So 9 times 9 squared. And we have 9 times 12 squared as well. So 345. So probably if I get some number out there. That becomes 9 squared. Probably 9 and 12, and I would say 3, 4, 5. So it becomes 15 squared. Okay, so that becomes 4 squared as well. So if I get rid of all those parts, I would say that becomes 9 times 15 times 4. So I would say 60 times 9. It becomes 540. And I would say the answer for our AIME question must be 540.